Hey guys, this is lesson 9.3, experimental probability. So lesson 9.2 was talking about theoretical probability, which I mentioned was when everything works out perfectly. But things don't always work out the way that you hope. So experimental probability is the probability that based on repeated trials of an experiment. So the theoretical probability is what should happen. The experimental probability is what happens once you do the experiment. So it's very similar, except instead of hypothetical, this is actual. So in this setup, it's the number of times the event occurs over the total number of trials. How many times did you try it? How many times did the event happen? Okay, so let's do an example. Here it says 13 out of 20 emails in your inbox are junk emails. What is the experimental probability that your next email is junk? So 13 out of 20. So the number of times the event occurred was 13, and the total number of trials was 20. So we get 13 out of 20, and when you simplify that, you realize, oh, it's already simplified. But you still have to put it in a percent. So you do 13 divided by 20, you get 0.65. You move the decimal over twice, and you get 65%. So the correct answer is D. Your turn. I want you to find the experimental probability of drawing these different items. Now notice you have to first come up with the total number of marbles. So it says that we had different trials. We had 4 blue, 6 red, 4 green, 2 yellow, 3 orange, and 1 purple. So you have to find your total first. All right, go ahead and try it. All right, if you counted correctly and you set it up correctly, you would have gotten that you had 3 over 10 or 30%. Okay, so it's important that you give me the simplified fraction and the percent because this will help you become more proficient in probability. So let's really quickly do it. Drawing red. How many red do we have? We have 6. And if you counted all of these up, you would have gotten that we had 20 trials. That doesn't mean we had 20 marbles, but we had 20 trials. And so it's 6 out of 20. And when you simplify that, you get 3 out of 10, which is 30%. Number 2. If you did this correctly, you would have gotten 9 out of 10, which is 90%. And if you counted these correctly, you would have gotten that there are 18 different trials that were not yellow. So 18 out of 20. Simplify that, you get 9 out of 10, which is 90%. All right, let's move on. It rains 2 out of the last 12 days of March. If this trend continues, how many rainy days would you expect in April? So first we have to find our experimental probability of rainy days. So 2 out of 12 days. So how many times did it happen? 2 out of a total of 12. So we simplify that, and our probability of rain is 1/6. All right, and now we have to try to predict or figure out how many times we think it will rain in April. So 1/6 of the days will rain. At least that's our experimental probability. So we have to do 1/6 of the days in April. Of is multiplication. So 1/6 times 30 days, and we get 5. So we can predict that there will be 5 rainy days in April. Okay, so that's just a prediction. It may not happen, but based on our probability, that is what we expect to happen. Your turn. Go ahead and try number 3. All right, if you did this one correctly, you would have gotten 6 times. If not, go ahead and listen. Here we go. It says you must stop at 3 of 5 stoplights. So that's our probability of how many times we're going to have to stop on a stretch of road. If this trend continues, how many times will you stop if the road has 10 stoplights? Okay, so 3 out of 5 stoplights on a stretch of road will make you stop. So 3 out of 5 of 10. So 3/5 of 10. So we take our probability, multiply by how many times there are stoplights, And based on this multiplication, we'll get 30 out of 5 So we get 6 times. So if the trend continues, we believe we will stop 6 times on a road that has 10 stoplights. All right, another example. Here we go. It says the bar graph shows the results of rolling a number cube 50 times. Remember, a number cube is a 6-sided dice, 1, 2, 3, 4, 5, 6, all right? And you roll it 50 times. What is the experimental probability of rolling an odd number? How does this compare with the theoretical probability? So if you remember from theoretical probability, it's a perfect situation. How many odd numbers are there? There's 3. Out of how many total numbers? 6. 1/2. So the theoretical probability says that if it was a perfect world, we'd roll an odd number half of the time. But let's find the experimental probability. So the experimental probability is when you actually roll the dice and find out the numbers. So we roll it 50 times. We rolled it 10 times for 1. Whoops, my line is too low. 10 times for 1. We rolled it 8 times for 3, and we rolled it 8 times for 5. Okay? So we have to add all of those up, and we get 26 times out of 50 rolls. So the experimental probability is 26 over 50, which is 13 out of 25. The theoretical probability is what we expected to happen if it was perfect. So 3 odd numbers out of 6 numbers, so it's 1/2. So the experimental probability ended up being 52%, whereas if it was a perfect situation, it would have been 50%. So we can say, because they're really close, the experimental and theoretical probabilities are similar, okay? And if it was very different, we could say they are very different, just like that, okay? So it doesn't, I'm not looking for a lot of vocabulary in your explanation. All right, go ahead and try this example. Okay, on this example, you should have gotten that the theoretical probability is 1/2, which is 50%. But the experimental probability you should have gotten was about 5 out of 12, which is about 42%. If you don't know how I got those, let's go over it. So it says your teacher has a large box containing an equal number of red and blue folders. So in this case, we don't know how many total folders she has. We just know that she has an equal amount of red and blue folders. So theoretically, if I were to reach into that box and pull out a red folder, what's the probability I will get red? Well, it will be half of the time because there's an equal amount of red and green. So that's why the theoretical probability is 50%. Now the experimental probability says there are 24 students in your class, and the teacher passes out the folders at random, and 10 students receive a red folder. So that means 10 out of 24 students got a red folder. You simplify that to 5 out of 12, and you get about 42%. Now I say about because I rounded it. Okay, so when we compare the experimental probability of receiving a red folder with the theoretical probability of receiving a red folder, you can see they are somewhat similar. But we could say the experimental probability of receiving a red folder is slightly less than the theoretical probability of receiving a red folder. So that's one way we could compare them to write a sentence. Okay? All right, we'll go over more of this in class next time. If you have any questions, please let me know.